All right, welcome everyone. This is the Chemistry Girl, and today we are talking about an introduction to chemical equations. So get a piece of paper and a pen and follow along. To introduce chemical equations, the first thing we need to know is what a chemical equation is. And so a chemical equation is a symbolic representation of a chemical change. So if we have a chemical change occurring, we can symbolically represent it using a chemical equation. So for example, say we have a piece of magnesium and we light the magnesium on fire so that it's now burning and it's on fire, flames are going, and it's going to give off a lot of bright light. Okay, it's going to give off a lot of bright light. This burning process is a chemical change. And so we can represent that using a symbolic representation or a chemical equation. And so when magnesium burns, it actually combines with oxygen and it makes magnesium oxide. So let's go ahead and see if we can write that out. Magnesium metal burns in air to produce magnesium oxide. So if I were to write out a sentence explaining the burning of magnesium, I would write out magnesium metal burns in air to produce magnesium oxide. This is not a chemical equation, this is a sentence. And so I'm going to use this sentence and I'm going to produce a chemical equation from it. So this first part, magnesium metal, we can represent this as the element Mg, which represents or is the symbolic representation for magnesium. Burns in air is always represented by adding O2 or adding oxygen. Now oxygen is always represented as a diatomic element, and so that's why I wrote O2. To produce is always represented by an arrow. So these magnesium and oxygen are reacting to produce magnesium oxide. So if we go back to Unit 6, remember that we are drawing magnesium oxide. Remember that Mg, this is an ionic compound, and magnesium has a 2+ charge, and oxygen has a 2- charge. Remember, I get these charges from the periodic table. If you've forgotten how to write ionic compounds correctly, then go back and look at previous videos from Unit 6. And when we combine these, we only need one of each because the charges are equal and opposite. So I'm going to write this down here. I'm actually going to erase this, and I'm going to rewrite it. I'm going to write this as MgO. This is magnesium oxide. And just as a reminder, the Mg is +2 and the O is 2 negative, and so I'm combining them in a 1-to-1 ratio to produce magnesium oxide. So now what we can see here is that this is a chemical equation that represents the chemical change of burning magnesium in air. Just as a reminder, remember that burning in air is always, what that always means is add oxygen gas. Okay, So now I have this chemical equation here. If I wanted to represent it in a particle diagram, what I could do is the magnesium is going to be 1 dot to represent a magnesium atom. The O is going to be represented, the oxygen is going to be represented by 2 dots, and those dots are going to be bonded together. And then I have the arrow, and then I have 1 Mg bonded to 1 O. Okay? And so now, one other thing that I want to add in here, just going to get rid of some of my other arrows here, is that the things that are on the left side of the arrow, so this section on the left side of the arrow, let me use a different color. I'll use yellow. These things on the left side of the arrow we call reactants, because those are the things that are reacting together. They happen before the reaction takes place, and then they combine together. And then after the arrow, so if we think of the arrow as a dividing line, after the arrow, I'll use green, everything on the right-hand side of the arrow called the products. And the products are after the reaction has taken place, we've produced something new, and we produce these products. And so we could think also as these molecules down below as being the reactants, and they're combining together to produce this product. Now, you might have a question, and you might say, well, look, I have 1 red dot over here, and it shows up on the product side, but I have 2 blue dots over here, and only 1 blue dot on the product side. And so therefore, the law of conservation of mass is not obeyed. So, that's an issue. To learn more about how to balance chemical equations to obey the law of conservation of mass, make sure to watch the next video on balancing chemical equations.